All right, Unit 1.6, Part 2 of guided notes, because we're going to take it to the next level. You'll notice that these variables have exponents, right? Terms with the same exponents or combination of variables and exponents are considered like terms, right? But they have to have either the same exponents or a combination of variables and exponents. When combined, don't change the exponents. Right? So let me show you what I mean by this. Alright, these are both x squared. So they can be combined. Your answer is 12x squared. Right? I added the coefficients and then I brought down the common variable. These are both n to the 5th power. So negative 15 plus 4 is negative 11, and then I just bring down the common variable. C cubed, C cubed, C cubed. Bam, bam, bam. They're all the same. So looking at the coefficients, 8 minus 7 is 1, plus 16 is 17. And we just bring down the common variable. This is where things get interesting. The variable is the same. They're all k's. But this one is k to the invisible first power, k to the invisible first power. And these are k to the second power. So, alphabetical, right? Let's remind ourselves, standard form. Alphabetical, sorry, I forgot how to spell it for a second. Highest to lowest exponent constant last. Constant is always going to be last. Alright, so let's do this. K to the second power is the highest exponent. So 8 minus 2, because these can be combined. They have the same variable to the same power, to the same exponent. Right? So it's going to be 6k squared. And then we have negative 1k minus 5k. So you have negative 6k. They have the same variable to the same invisible 1 exponent. And then the only constant up here is 7. Alphabetical, highest exponent to lowest exponent, constant last. I know, it's getting a little insane. That's okay. We can do this. Alright. This is a squared b to the first. And this is a squared b to the first. They are like terms, so let's combine them. Negative 4 plus 10 is 6. A squared b to the first. And then we're left with this constant. Now, if you had 3, wait, let's change colors. This is going to be wrong. I need you to pay attention. This is going to be wrong. If you had 3a squared b plus 2ab squared, they're not like terms. They have the same variables, but the a is squared on this one and the b is squared on this one. When I say like terms, I mean they have to be just alike. You can't do this. That can't be simplified any further because nothing can be combined in that. We have an x squared, an xy, an xy, and a y squared. Be careful. Alphabetically, x comes first, and then you do highest exponent. So x squared is first. There's nothing to combine it with. Then you have xy, which comes before y. Think about the dictionary. Xy comes first. So 2 minus 7 is negative 5xy. And we're left with this positive 4y squared. That is the appropriate order and combination of those terms. They're going to make it even harder for us. That's okay. A squared, AB, and B squared. This is a lot like 14. You know what? I'm not going to work that one. You are. X squared, X squared, X. Let's take a second and do what I said about putting like terms together. They're all X. So we're going to do X to the highest power. So we're going to do 4x squared minus 3x squared. You notice how I'm taking the sign with me? And then we're going to do plus 2x plus 8x minus 7 minus 6. Alright, so this is a step you can do if you need to. It's not required. But sometimes it helps to see it all lined up like this. This and this get combined. You're left with 1x squared or x squared. Let me change the colors. You're left with 1x squared or just x squared. You don't have to put the 1, it's invisible. 2x and 8x is 10x. Negative 7 minus 6 is negative 13. It looks insane, but it's actually very simple. Just combine the things that are alike. And why do we need to be able to do this? I'll show you why. Right? Geometry comes into play. Right? Let's see. How many are there? Okay, we don't want to do all of them. Let's do the odd ones. Given the perimeter of each figure, give the perimeter of each figure as a simplified expression. Perimeter is the outer boundary, right? So the perimeter of a square would be 4 plus 4 plus 4 plus 4. The perimeter is 16, right? So all you have to do to figure out the perimeter is add up the outside. 2x plus 1 plus 3x plus x. And it says simplify. So combine your like terms. We have a 2x, a 3x, and a 1x. 6x. And we're left with one constant. That's the perimeter, 6x plus 1. So once you know what x is, you could figure, like if x is 2, that would be 6 times 2 is 12 plus 1 is 13. The perimeter would be 13. Because we don't know what x is, that's as far as we can go. Alright, let's do 19. Oh, they tell us so much with this picture. Perfect squares. We know that that means 90-degree angles. Oh, thanks. Thanks, drawing. Right? And we know because we're doing perimeter that this has to equal this because of the perfect squares, right? So this is also 3y minus 5. And that this has to equal this because of the perfect squares, so y plus 2. Then you just add them all together. 3y minus 5 plus 3y minus 5 plus y plus 2 plus y plus 2. And then just combine your like terms. We have 3y, 6y, 7y, 8y. 8y. And then we have negative 5. Negative 5 is negative 10. Plus 2 is negative 8. Plus 2 is negative 6. All I did was combine all the like terms, and we get to see. Hello. Hi. What you doing?